So in today's lecture, let's see a few properties of sets. I've just listed down the three main and basic properties of sets. One is commutative property, second one is the associative property, and the third is the distributive property. Much like addition and multiplication, properties of sets follows these three rules. So let's see how they work. Suppose we have A union B. Commutative property of union of sets means A union B is equal to B union A. Or if you take the case of intersection, A intersection B is equal to B intersection A. We will go through a few examples, numerical examples to make this more clear. But here I just wanted to give you guys a brief idea of what we're exactly going to achieve today. And in the associative property, what this means is A union B union C, so let's put parentheses here, is equal to A union B union C. And if you take the case of intersection, A intersection B intersection C is equal to A intersection B intersection C. Distributive property means A union B intersection C. This one is probably slightly complicated, so I have divided this lecture into two parts. This one is the first series, part 1, and next we'll be looking at part 2, in which I extensively cover distributive property. So anyway, A union B intersection C is equal to A union B intersection A union C. Now the other rule is, if you have A intersection B union C, this means A intersection B union A intersection C. So let us see how we go about proving these using numerical examples. So let's start with commutative property. Let's consider A is equal to just some set 6, 7, 8, and B is equal to some set 4, 8, 12. Now, commutative property of union of sets means A union B is equal to B union A. So let's see what A union B is. We have to list the union. If you guys don't know how to do this, I have a few lectures on this. Please go back and visit them. I will also leave these links in the description below for you guys to check it out. So A union B is, first let's write all the elements of A, 6, 7, 8, and then of B without repeating any elements. So 8 is common again, so let's leave out 8 and 12. If you want to write this in ascending order, actually I should put these parentheses instead of these. So if you want to write this in ascending order, it is 4, 6, 7, 8, 12. Now let's do the same for B union A and see what we get. Write down all the elements of B first. That's 4, 8, 12. And then list out the elements of A without repeating anything. So that's 6, 7, and 8 is common, so we leave that. Let's arrange this in ascending order. So that's 4, 6, 7, 8, and 12. As we can see, these two here are the same, right? So this proves that A union B is always equal to B union A. Now let's see intersection of sets. Let's see how the commutative property works there. So intersection. Okay, so we do A intersection B is equal to B intersection A. Let's see what this is first. So A intersection B. Whatever the common elements are, we have to list them out. So let us see what the common elements are. At this point, we see that 8 is common. So let's list out 8. And if you do B intersection A, same thing. You put B and A below each other and see what the common elements are. Again, there's no change there, so it is still 8. We see that it's the same again, right? So this means, now let's see another property, which is the associative property. First, again, let's do union of sets. Okay, so in this case, we saw that it means A union B union C is equal to A union B union C. Let's just take an example of A is A, B. Actually, let's do another example. Let's do a numerical example so you guys understand that better. A is 1, 2, 3, 4. B is 3, 4, 5, and 6. C is 6 and 7. So what is A union B? Let's list out A first, 1, 2, 3, 4. And then let's list out B without repeating anything. So we see that 3, 4 are common, so we'll not repeat those. 5 and 6. Now A union B union C. That means first we list out these here. That's 1, 2, 3, 4, 5, 6. And then list out C without repeating. So 6 is repeated, we leave that out. That's 7. Now we do the same with the right hand side, RHS. So let's just say this is LHS, which means left hand side. So for RHS, let's do another color so we don't mess this up. First, we got to do B union C. What is that? B union C, first you list out B, 3, 4, 5, 6. Sorry. And then you list out C without repeating. So 6 is repeated, we leave that out. That's 7. Now let's do B union C, but with A union. That means first we list out A, which is 1, 2, 3, 4. And then we list out B union C without repeating. That's the key. 5, 6, 7, which is RHS. Now if you compare these two, they are the same. So LHS is equal to RHS, which proves that union of sets follows the associative property. Now let's see the intersection of sets, if it still follows the same thing. The rule is A intersection B intersection C is equal to A intersection B intersection C. So let's first do A intersection B. A intersection B is 3 and 4, just the common elements. And now we do intersection of this with C. We see that there are no common elements, right? So it's a null set, which can also be written this way. Next we do B intersection C. Only common element is 6. So that's it. And now A intersection B intersection C is, what is it? There is no set again. That's a null set. This is LHS. This is RHS. Therefore, LHS is equal to RHS. Now this again proves that intersection of sets holds good for associative property also. That's it for this lesson. Thank you guys for watching. If you have any comments on the way I'm teaching these, please let me know in the comment section below. If you like this video, give it a thumbs up and subscribe to my channel. I will be uploading more videos as I find time. If you guys want to see some new topics, share with me. Let me know. If you think this video is going to help your friends out, please share it with them. Thank you all.